So let me start my class by solving this question first.
Sir, is the answer to the first one minus 4FR?
Why minus?
So
And
because it is going anti-clockwise.
so force direction is not specified. You can take the force to be in the same direction.
Sir, I went out for some time. Sir, can you please repeat from first?
I have just started my class. No problem. So this is the first question that we will take today. A particle of mass m moves in a circle of radius r. It starts from A, completes one circle in anti-clockwise direction. What is the work done by the force that I have to calculate? So if I say that suppose this is the circle where the particle is moving, right? And let us assume that this is the starting point of this particle here, and after some time the particle reaches at this point at an angular position theta. So now I have to first judge whether, whenever we are solving a question on kinematics, I have to first judge that whether the particle is moving in with a variable force, or is it moving with a constant force. What type of force is acting on this particle in this particular example? Constant or variable? What type of force is acting on this particle?
Constant.
Yes?
So for the first one, it's constant.
Okay, if you are saying that a force is constant, then what are the things that you have to make sure that they are constant? Only magnitude or magnitude directions both?
The tangent direction is 0.
Magnitude and directions both. So in this case, if the force is always acting tangential, so can you say that the force is a constant force, because at this point
No.
the force is along
So
this
the
line.
direction is changing.
Yes. At this point the force will act in this direction. So although the magnitude of the forces are same, can I say that the forces are actually same? No. Right? So I have to find the work done by process of integration only, because we know that work done by variable force is integral of f dot ds. Now let us assume that this angular position is theta, and the particle in a very short time interval covers this angle d theta.
D theta.
Yes. So if the particle covers this angular position d theta with this force F, let us assume this force F to be constant for this small time interval. And what will be the displacement of this particle during that small displacement? What is that?
RD theta.
It is RD theta. So I can say that this RD theta and displacement and force, they are in the same direction, yes or no?
Yes, sir. So just multiply.
F into RD theta, yes. So I can say that dW is equal to F into RD theta. And what is the total work done in this entire process? So for this entire circular motion, what is the angular position?
Angle top is 0 থেকে 2 pi. Sorry,
Yes.
2 pi at 0.
The angle the particle is covering is from 0 to 2 pi.
2 pi.
So the total work done, I can say it is F into R is a constant, and what is integral of d theta? It is nothing but 2 pi here.
So 2 pi FR.
Yes, that is the answer for the first question. Now in the second part, dW is the same, F into RD theta, but instead of F is a constant that I have taken here, I cannot take F to be a constant, and I cannot take it out of the integration. So what I will do, instead I will keep this as F naught into theta square.
Function form mein to dewa ache.
Yes, into d theta, right? R you can take out.
F naught is a constant.
F naught is a constant.
Yes, sir.
So F naught and R you can take outside, and now theta will vary from 0 to 2 pi.
Theta cube by 3. So 2 pi cube by 3. So 8 pi cube by 3.
So 8 pi cube divided by 3 into F naught R. That should be the answer for the second question. So this was work done. Now we will talk about work done by friction force, right? Look here, this is a very good question. We have solved this question in friction. Do you remember two body problems in friction questions?
Yes, sir.
Yes. So first you need to find out the accelerations or friction force,
Common
displacement.
acceleration, then
Yes.
the
Then displacement. So in 2 seconds, you have to find the work done by friction force on the system. When I am saying on the system, you find work done on 2 kg blocks separately, you find work done on 6 kg blocks separately by friction force, then you just add those. Right? Can you solve this question now?
the total work done.
Total work done on the system, yes.
Okay, sir.
Okay. Look. In the first case, horizontal force acts on the 6 kg block, right? So this is the 40 Newton force acting on the 6 kg block. So in this case, what is the common acceleration of that body? Can I say it is 5 meter per second square?
Yes, sir, absolutely.
And if you see that which block is just moving with the friction force, the 2 kg block.
2 kg, sir.
So on the 2 kg block, what is the friction force? In which direction it will act? Tell me.
সামনের দিকে, রাইটের দিকে.
So what is the maximum value of that friction force acting on 2 kg block?
12 Newton.
12 Newton.
স্যার একটা কোশ্চেন আছে স্যার।
হ্যাঁ বলো।
এই ম্যাক্সিমাম ভ্যালুটা মানে নরমাল রিঅ্যাকশন অফ দ্য 2 কেজি ব্লক মানে
normal reaction
নরমাল রিঅ্যাকশন ওটা তো
at this surface normal reaction on
মানে
the
যে
2 kg.
বডির উপর অ্যাক্ট করছে নরমাল রিঅ্যাকশন।
Yes.
ওকে স্যার, ওকে।
So what is that normal reaction is 20 into 0.6. So what is maximum acceleration for 2 kg block?
6 মানে ওটা কমন
6
অ্যাক্সেলারেশন
meter per
নিয়ে যাবে।
second squared, yes. So as it is greater than common acceleration, so it has no problem to move with common acceleration. So acceleration of 2 is equal to acceleration of 6 is equal to 5 meter per second squared.
5
Yes or no?
হবে 5।
So what is the
Yes.
friction force on 2 kg block?
10 Newton.
10 Newton. Now it will not take 12 because it is moving with 5. So 5 into 2, 10 Newton will be the force on 2 kg block.
So please repeat, sir, F2.
Now the 2 kg block is moving with this 5 meter per second square. So what will be the friction force now? Is it 2 into 5 only? Yes or no?
Oh, yes, sir.
And what will be the value of friction force on that 6 kg block?
That will be
Yes.
same thing.
Same in opposite direction, right? So
Yes, sir.
F6 is equal to minus 10.
Minus 10. 0.
What is
Yes,
the
yes.
displacement of the 2 kg block? Is it half into 5 into t square? 10 meter. And what is displacement of 6 kg block? Is it the same thing because they are moving with the same acceleration? Yes or no?
স্যার একটু ওই পার্ট থেকে বলবেন স্যার A2 equal to A6 থেকে একবার বলুন।
A2 equal to A6. Why? Because they are moving with common acceleration.
হ্যাঁ ওইটা ঠিক আছে, তারপর 2 এর বডিটা যেটা ড্র করলাম
বলো। তারপর 2 এর বডিটার উপর ফ্রিকশন ফোর্স
2
সামনের
কেজি
দিকে।
বডিটা
ফ্রিকশন ফোর্সের সামনের দিকে, yes or no?
হ্যাঁ ইয়েস স্যার, ওটা 10 নিউটন হচ্ছে।
10 Newton. So the same 10 Newton will act on the 6 kg block in opposite direction. Then displacement is simply half at square. Yes. So what is
Okay.
work done by friction on 2 kg block? 10 into 10, both are positive. So plus 100. And what is work done by friction on 6 kg block? On 6 kg block, what will be work done? Minus 10 into
অপোজিট
plus
দিকে তাহলে মাইনাস হবে তো।
minus 100. So net work done by friction on the system is equal to 0.
I never thought this.
Right? So here
Sir.
you should, yes.
Sir, I think I made a mistake. Like I got the answer 0, but as soon as I got both the frictions to be the magnitude of same, but the
Yes.
direction opposite, For taking the net, I added them, and because the net force was coming below, I told the answer to be 0. Like,
No,
was my
that you
assumption
can do
correct
in
or
this
wrong?
case, definitely. In this case, that you can do because both of them are having the same acceleration. That is why you have got
So
answer.
what is the assumption?
Not
Like, I
assumption.
took the net force to be 0. Like,
He
directly.
said that the net force is 0, so the net work done is 0. But that is not always true. In the next question, you will see that although the net force is 0, but net work done is not 0.
ও এখানে কমনে চলছে বলে হচ্ছে।
Yes, here the displacements are same. That is why it is 0.
স্যার মানে আমরা পুরো সিস্টেমটাকে সিঙ্গেল অবজেক্ট হিসেবে কনসিডার করতে পারি, সেটা
Yes.
দেখলে সিস্টেমটা
Yes.
ফ্রিকশনের কোনো কাজ করছে না।
ঠিক,
ডিসপ্লেসমেন্ট এখানে 0 হয়ে গেছে।
So here you should remember one very important point, that static friction does not do any work on system.
হ্যাঁ, because the system's displacement is 0.
Yes, right? You cannot say, if I say that work done by static friction is 0, that is not a complete statement. Work done by static friction on the system is 0, not the individual bodies. On the individual bodies, work done may be anything. Have you understood this point?
Static friction ও work done করতে পারে।
Here, the static
Why-
friction is
why
doing work done on 2 kg block, yes or no? Here also the static friction is doing work done on 6 kg block, but the net work done on the system is always 0.
Okay, sir.
Right? When you are walking, when you are moving on a floor, the friction that acts on your shoe is what type of friction? Static or kinetic?
Static.
And will that friction do any work?
No, sir.
No, because the point of application of that friction force is not displacing.
ওকে স্যার।
Alright?
Okay, sir.
তাহলে আমরা হাঁটার জন্য তো মানে কাজটা কি করে হয়?
That work is done from your muscle energy, right? That is not
Okay,
work done
okay,
by friction. Alright. Now a
তার মানে 2
horizontal
kg ব্লকের
force,
জন্য স্ট্যাটিক ফ্রিকশন ওয়ার্ক করছে তো
কিসের জন্য?
2 kg ব্লকের উপর।
Yes, also on 6 kg block, but the total work done
Okay.
is 0. Now if I apply the force on 2 kg block, then the common acceleration is 5, but now which block is only moving due to friction?
The 6 kg block.
6 kg block.
6 kg block, sir.
So what is the maximum force on that 6 kg block, friction force?
12 Newton.
The same 12 Newton,
12 Newton, sir.
because the same
There is a
normal
reaction force from that 2 kg block.
Yes. So what is the maximum acceleration for 6 kg block?
Sir, 2 meter per second.
2 meter per second square. It is less than common acceleration. What we can say from here? Can we say that the system is not moving together?
Sir, your voice is cracking.
Yes, sir.
Hello.
Yes. Can you hear my voice?
Yes,
Yes,
I'm between cracking, sir, sometimes.
All right. Look to this solution. What is the 6 kg block maximum acceleration? Is it 2 meter per second square? Yes or no?
Second square. Yes, sir.
Yes.
Yes.
So in
Yes,
this
sir.
case, will they move together or they will move separately?
No, sir, they will not
Separately.
separately.
They will move
Single.
separately. Yes. They will move separately. So if they will move separately, what is the acceleration for 6 kg block then?
2 kg. That is 19.
2 meter per second square.
2 meter per second square.
And what is the acceleration
6.
for 2 kg block? Can you tell me now?
So 19.
No.
15.
For 2 kg block, this is 40 Newton force acting. In which direction friction force will act?
Opposite direction.
The opposite direction.
And what will be the value of that friction force?
Oh,
12 Newton.
So what is acceleration of 2 kg block?
14.
14 meter per second square. Right? Now, what is the displacement of 6 kg block? half into 2 into 2 square, so that is 4 meter. And what is displacement of 6 kg block, 2 kg block?
The 28 meter.
28 meter. So
28 meters.
and what is friction force on 6 kg block? Plus 12.
Yes, sir.
What is friction force on 2 kg block?
Minus 12.
That's 12.
It is minus 12. So what is work done by friction on 6 kg block? 48 joules. And what is work done by friction on 2 kg block?
12 into 14. So that's
28.
168. 168.
Yes.
Minus 336.
Minus 336
Oh.
joule. So what is the net work done by all the forces? Net work done by friction forces? It is minus how much?
288.
288 joule. That should be the answer.
So means we are considering the direction of motion as positive.
Yes. In this direction I have taken positive and opposite direction negative. Even if you take the reverse direction, you will find the same answer.
Actually, when both are in same direction, that time the work done is positive.
Work done is?
When both the force and displacement are in same direction, then
Yes.
the work done
Yes.
is
Yes.
positive.
Yes. So from here you can conclude one more thing, that work done by kinetic friction on the system is always negative. Right? Work
Sir,
done.
how?
From here you can see that for a system there will be a relative motion, right? And in relative motion, the
So can I say, sir, once, can I try?
yes,
Yes, sir. So means for the block on which the force is acting,
yes,
for that block the friction will act in opposite direction. And that block will have more acceleration.
yes.
So like that, it will have more negative value.
Good. Yes. So when you apply some force on a block, so it will have more acceleration than the one which is only moving due to friction force. So its displacement is more, but friction force on it will be negative. So in that case, it will have a more negative work done by friction than that of the block which is only moving due to friction. So that is
Yes,
why
sir.
work done by kinetic friction. Right? I'm talking about kinetic friction is negative on a
Sir,
system.
if the motion is in the negative direction, then the kind
Now look, work done is also dependent on reference frame, right? So that you need to understand that work done is F dot delta S or displacement. Now displacement depends on reference frame, right? If you are moving 5 meter along x-axis and I am also moving 5 meter along x-axis, then with respect to me you do not have any displacement, right? So in that case, the work done by by any force on that block is also dependent on the reference frame. So try to solve this question with this example, that find work done by 40 Newton force and friction force on the system of not on the system. Here we cannot find on the system because it is a car.
On the
So,
block.
on the block only, right? Only on the block. Calculate the work done
Separately,
by,
we have to calculate. So,
yes, work done by 40 Newton force and work done by friction force on the block only in 2 seconds with respect to the observers. You can see now there are two observers, observer A and observer B. B is inside the car and A is outside the car is moving with 2 meter per second speed.
মানে A respect work done এই দুটো force আর B respect
Yes,
দুটো force
actually you
work
need to
done.
calculate 4 answers.
Yes, sir.
Okay. So let us solve this question. Well done by first tell me that with respect to the car, what are the forces acting on the block? With respect to the car, if I try to draw its free body diagram, right?
40 Newton and friction force.
With respect to
Wait.
the car, can you tell me what are the forces acting on this?
So 40 Newton and friction force.
And pseudo force? What about pseudo force?
The no pseudo force.
So no pseudo force, I think.
With respect to the car, there will be no pseudo force.
No, sir. Sir, means what I think.
What is that car reference frame? Is it a inertial reference frame or non-inertial reference frame?
So, but the box is also inside the car, no?
So what? You have to only consider the observer. Reference frame means observer or object. Observer. So if the observer is inside the car, then will there be no pseudo force? Definitely there will be a pseudo force. What is the, it is with respect to the car. If you draw with respect to the person, that is a different issue. But I am drawing with respect to the car. So this is 40 Newton and that is 10 Newton. So what is the net force? 30 Newton, and the net maximum friction force is 25 Newton. So definitely friction force will be 25 Newton here, and the body will accelerate with a relative acceleration. Relative means acceleration of the block.
So please repeat this part.
This is a free body diagram. I am drawing.
So for the man B,
Yes.
the box is also it is inertial frame of reference for the man B.
How a reference frame can be with respect to some other reference frame?
No, sir, I am saying that the box আর কার মানে আমি কারের ভিতরে আছি আর বক্সও কারের ভিতরে তাহলে আমিও একে অ্যাক্সেলারেশনে আছি
আমি ভিতর বসে আছি সেই রেসপেক্টে নয়।
Have you forgot the concept of pseudo force? What is pseudo force? For example, suppose this car is moving with acceleration and a person is moving outside the car with an acceleration A. If I want to draw the free body diagram of this block with respect to that observer, what will be the forces I will draw? If I give it a force F, what is the free body diagram? What are the forces that I am going to give it?
The friction, force F and pseudo force.
Why you are saying pseudo force? Now you are saying pseudo force because only the reason that person is outside of that car. Person is outside of the car, but person is also moving with the same acceleration. So what is the difference between this observer and this observer? Are they same or different?
It's the same.
Then
So, but I am saying that that train and I, we don't have any relative acceleration with respect to each other.
who said that the block and the person does not have any relative acceleration? How you can say that? After drawing free body diagram, only you will be able to say that whether there is a relative acceleration between them or not.
Okay, sir, understood.
Yes or no? That is a very basic concept of pseudo force. I said that there are only two properties of pseudo force that you need to remember. No other thing. If you apply other things, then you will get wrong answer. What were those two properties? Do you remember? Two properties of pseudo force.
It is equal.
Yes. First property was that it only is applicable from
Acceleration of the reference frame.
yes, from a non-inertial reference frame, and the second is the force is minus mass into acceleration of the reference frame. Only these two things you need to remember. No other thing, no other logic, because these things are related with Newton's laws of motion, and you have not prepared that law, right? So let us stick to that
First
law.
is what the first one?
First one is that only on a non-inertial reference frame I can use that force. Is that clear now? Or is there any doubt? You can ask me. What is the free body diagram of that block with respect to the reference frame B now? With respect to the car or with respect to the
Sir,
reference?
can you please repeat from the beginning? I was out.
I am saying that with respect to the observer B, I am drawing the free body diagram of the block. Then what are the forces on the block that I need to first calculate? So with respect to the car, can I say that there is a pseudo force 10 Newton pseudo?
Yes.
Because the observer is also moving with 2 meter per second square. So with respect to observer, the block definitely I have to keep a pseudo force and 40 Newton acting in this direction. So the net force is greater than the friction force, the maximum value of the friction force. So what is the acceleration of the block with respect to the person B? Can you tell me what is the acceleration with respect to the person B?
3 meter per second square.
Yes, how you
1
can
meter
say
per second square.
1 meter per second square. 40 minus 25 minus 10, that is 5.
Oh, with respect to B, you told, no.
Yes. With respect to B, is it 1 meter per second square?
Yes,
only?
yes, it is 1 meter per second square.
Yes, sir.
Right? If I say it is I cap, then also you can say that. Right? Or let us take in this direction.
To A, it is 3.
Oh, one second. Yes. Right?
Sir, I was out for a moment, sir. So means you were explaining that only, sir.
Yes, I am only finding the acceleration with respect to B. So with respect to B, the acceleration is 1 meter per second square. So with respect to B, now the force does not depend on any reference frame. Force is 25, friction force is in any reference frame, it will be 25 only. So in 2 seconds, what is displacement of the 5 kg block with respect to the observer
2
B?
meter.
Can you tell me?
2 meter.
2
Yes.
meter.
Half A into T square. So that is 2 meter positive.
Yes.
So the relative acceleration will give.
Yes. So what is work done by friction force with
25 into
respect to B?
50 joule.
Minus 25 into 2. Minus 50.
So it is minus 25 into 2. So that is minus 50 joules. Have you got this one?
Yes, sir.
Yes, sir.
And
Yes, sir, got
with respect to B, what is work done by 40 Newton joule?
80 joule.
80 joules.
It is 40 into 2, it is 80 joule. Have you got my answer?
Yes, sir.
Yes. Total
Now.
work done is
So I didn't take the pseudo force, sir. For that, my whole
Yes,
was wrong.
I say that you have to draw the free body. Alright. Now, what is the...
Sir,
Yes.
that means total work done is 30 joule.
Total work done means, are there any other forces with respect to B? You
No,
have
sir.
not considered
Yes, sir,
the
pseudo.
pseudo force, yes. So what is work
Pseudo,
done
sir.
by 10 Newton force on
Okay.
with respect to B? Can you tell me what is work done by 10 Newton force with respect to B?
Minus 20.
Minus
It will
20.
be just 10 joules.
Yes. So what is the total work done? You can see it is 10 joules. Total work done with respect to B by all the forces.
Total work done. Is there any other shortcut?
Yes, we will do it. We'll do it later.
Sir, we find the resultant force and then just multiply it with displacement.
You can do it. If the forces are in the same direction, you can multiply it.
Yes, sir.
Yes, you can do it. Alright. What is work done with respect to A? With respect to A, what is the acceleration of the 5 kg block? Can you tell me now?
3 meter per second square.
Yes.
3 plus
2 plus 1, 3 meter per second square, yes or no?
So we'll add them both.
Yes, because they are in the same directions.
First, so one is with respect to B and plus 2.
Yes. So what is displacement of 5 kg block with respect to A in 2 seconds? Is it 6 meter only?
6 meter.
Yes.
Yes, sir.
So what is work done by friction force with respect to A? Look, now the friction force does not change. Will the force change in reference frame? No.
No.
So work done by friction force is minus 25 into 6, yes or no? Minus 150 joules. And what is work done by 40 Newton force on the with respect to A? How much it is?
240. So
40 into 6. It is 240 joules. What is work done by 10 Newton force with respect to A? Can you tell me?
10 Newton force is not there.
Yes.
There.
You cannot find work done by 10 pseudo force because pseudo force is not there with respect to A. Right? So total work done with respect to A is actually, what is total work done with respect to A?
90 joules.
Yes, work done in reference frame of A is 90 joules, and you can see work done in reference frame of B is equal to 10 joules. Can you see that the work dones are different in different reference frame? Alright. Now look, a particle of mass m is slowly moved by a force F that is always tangential to its path. It reaches a height h. What is the work done by friction force? Can I find that?
Yes, sir. Yes.
Coefficient of friction is mu given, mass of the particle is m given, and the length and height of the path is given. But the path is any arbitrary path where the particle is slowly dragged. Calculate the work done by friction force.
8.
Nah, देखो. Look, this curve is any arbitrary curve, right? Let me draw any arbitrary curve like this. This is the base length L and this is the height h given in your question. Now, let us assume a very small segment from this curve. Right, let us take a very small segment from this curve and zoom it out. Let us check what is happening during the displacement of this small segment. You can see in this small segment what are the forces acting. Mg sin
Mg is
theta,
there.
Mg cos theta. If this angle is theta, I am assuming this angle is theta. Can I say that this is a very small triangular wedge?
Yes, sir. Very small.
Mg cos theta. This is normal reaction. There is a force F. Can you tell me what is the value of friction force and direction of friction force?
Yes, sir. Mu mg cos theta.
mg cos theta
That
down.
along
Yes.
mg sin theta.
So the friction force is mu mg cos theta. Why friction force is mu mg cos theta?
Mu n and n is equal to this because there is no
Because
motion in the direction of normal reaction.
yes, because the particle is moving actually. It is not at rest. So I will apply kinetic friction only. So kinetic friction force is, we can say that kinetic friction is mu into n, which is mu mg cos theta. Right. Look, now during that small displacement, suppose this is ds. During that small displacement,
Kinetic coefficient.
what is the work done by friction force? Can you tell me? What is work done by friction force during that small displacement?
Yes, sir. Minus mu mg cos theta ds.
Minus mu mg into ds cos theta. Yes or no? Right? If I have to
Yes.
find the total work done by friction, I will integrate this one.
Yes.
Mu into mg is a constant or variable? Mu into mg is a
Sir,
constant.
that's constant. Minus mu mg constant.
Now you can see that theta is also variable and ds is also variable. But what is
Yeah.
ds cos theta? From this triangle, can you see that ds cos theta is nothing but this dl? Yes or no?
Yes, DL. Yes, sir. It's along horizontal.
So can I say that I have to only integrate this dl length, and what is the integration of this dl length?
That's L.
0 to
Can you
L.
explain this again? I went off for a moment.
I said that work done by that friction force is minus mu ng into ds cos theta. If this length is ds, now
Yes.
ds cos theta I can replace it by dl only. Dl means the base length of this small
Sir,
triangle.
can you please repeat this part? That is out my complaint. Sir, displacement part.
Which one? I am saying that work done by friction is the friction force into displacement. Now the friction force is how much? Friction force, can you see, it is mu into mg cos theta. I can just write it as mu into n.
It's,
So if it is mu into mg into
Yes,
ds
sir.
cos theta, then work done is mu into mg into ds minus y, because work friction is opposite to the displacement. Then if I integrate this, you can take mu mg outside, but integration inside will be ds cos theta. Now what is ds cos theta? You can refer to the small
Yes.
triangle. Is it dl, the base length only?
DL.
So now I
DL.
have to only
Yes,
integral dl, and if you integrate dl, basically you are doing integration of all these horizontal base lengths. So if you add all these horizontal base lengths, what you will actually get?
DL.
L.
L.
So
L,
the
sir.
answer is minus mu mgl. Right?
Yes.
স্যার
Yes.
স্যার বলছি যে তার মানে যখনই কোনো ওয়ার্ক ডান বলতে পারবে কার্ভ পাতে, তাহলে তখনই আমাদেরকে ছোট কম্পোনেন্ট নিয়ে করতে হবে একটা।
অবশ্যই, কারণ ফোর্সের ডিরেকশন অ্যাঙ্গেল চেঞ্জ হচ্ছে।
আর স্যার আরেকটা প্রশ্ন ছিল।
ইয়েস, বলো।
স্যার বলছি যে ফ্রিকশন ফোর্স তো নন কনজারভেটিভ, তাহলে স্যার এটা এখানে পাথের উপর কেন ডিপেন্ড করছে না?
হ্যাঁ স্যার, ও তো
পাথের ওপর অবশ্যই ডিপেন্ড করছে, পাথের ওপর, পাথের শেপের ওপর ডিপেন্ড করছে না। এখানে ফ্রিকশন ফোর্সের এটা একটা পার্টিকুলার কেস যেখানে ফ্রিকশন ফোর্সের ভ্যালু এটা। ধরো যদি আমি এই কেসটাকেই, ফর এক্সাম্পল, if I drag this particle not with a very slowly speed, if I drag this particle with some velocity v, with some velocity v, can I apply the same concept?
Means some acceleration will be there.
Yes.
Acceleration থাকবে।
If there is some acceleration, or let us take no acceleration, I am moving it with a constant speed, v is only there. Can I use the same concept of work done by friction? Then also it will be minus mu mgl, or it will be different?
It's the same.
Sir, it should be same.
How?
Because
There is no acceleration.
I am not telling about acceleration. I am telling about that it is moving with a constant speed v.
Yes sir, the force
Still,
is
the
balanced.
net force will be zero on it.
Yes sir.
No. In that case, can you say normal reaction is only mg cos theta, or there will be mv square by r because of this curved path?
Oh, okay. Yes.
বাবারে। Yes, sir.
We will not interpret the circular motion in this case.
Yes. If you drop a block in this circular path, the block will gradually increase its speed. So if this length is L, can you say that work done by friction will only be minus mu mgl?
No, sir.
No.
No, sir.
Right?
No.
Here normal is not equal to mg cos theta. That you need to remember. So this is any particular case, or yes, yes. তোমার কথা কিছু শুনতে পেলাম না। আচ্ছা, তুমি বলছো এটা স্ট্রেট লাইন নিয়েছি। আচ্ছা, এটা ছোটটা স্ট্রেট লাইন নিয়েছি। But in this case, that straight line will also be a part of a circle. Yes or no?
Yes.
This straight line is a
Yes.
part of circle which has a radius. The radius is not infinity. So you cannot neglect mv square by r if there is some velocity. Yes or no?
Yes, sir.
Yes. So that is why I am saying that it is not always mu mgl. It is a particular case where you have got this minus mu mgl answer.
তাহলে স্লোলি মুভড এর সিগনিফিকেন্স কি মানে
মানে
কনস্ট্যান্ট
বিটা খুবই কম তো এমভি স্কয়ার আরটা
Yes,
খুবই
if
কম
it is
তো
single
অলমোস্ট
moving,
নেগলিজেবল।
then mv square by r I can neglect. I can take it 0. Yes or no?
ইয়েস স্যার।
Also, if that force is not tangential, can you use that same concept?
force is not tangential.
If the force is not tangential acting at a certain angle, will again the normal reaction be mg cos theta?
Normal reaction will change. Force will have a
Yes.
component.
In that case, the
Yes.
normal reaction will also change,
Yes.
right? So that is
Many
why
cases are there.
yes, many cases are, and this is a very particular case. So you can use this concept. Remember,
We need to touch it based on the question and the situation. The question is given.
yes, in this particular question, it is mentioned. Look, it is always tangential and it is slowly moving. These two conditions must be there in order to write n equal to mg cos theta. If you cannot write n equal to mg cos theta, I cannot write f equal to mu mg cos theta and I cannot integrate this one. Right? So the condition before applying this concept, this is a very important concept, right? Condition is that this is applicable only when this is applicable only when n equal to mg cos theta. A very simple question. Work done by the spring for an elongation x from its natural length. So the spring was in natural length. I have elongated it by x. What is work done by the spring force? As a spring which was initially natural length, right? Natural length. Now, if I elongate that spring by some distance x, by some length x, I have elongated it. So, what is the spring force at this instant?
kx minus kx.
Is it minus k?
Minus kx.
And if I further slightly displace it by dx, why I am slightly displacing it? Because the force is variable.
So please repeat from start, sir. I was out for a moment.
I am saying that if I elongate a spring by length x, then the force is variable. It depends on x.
Yes, sir.
So let us assume that for x, the force is minus kx. So I have slightly displaced it by further dx. So what is work done for that small displacement by the spring force? Can I say that is equal to minus of
k into x plus dx.
minus of k into x into dx? Yes or no? Can I
So
write
minus
this?
k dx.
Yes. If I now
So
integrate this,
So what is NL?
yes,
NL is what?
natural length. Natural length. So what is integration of this from 0 to x? Initially, when it was natural length, what is the elongation of the spring? Is it 0? Yes or no?
0. Yes.
Now it is when it is at x, so the work done is minus of half kx square. Right? Remember, the work done by spring force is minus half kx square.
So please explain the integration once more. Why that kx ds came? How?
Do you know the formula for work done? It is f dot ds, yes or no?
Yes, sir.
What is force here on this block, what is a spring force? Let us talk about only spring force, because I have to find work done by spring force. What is work done? What is spring force on that block?
minus kx.
What is the displacement? I have displaced it further by dx.
Say displacement is x, no?
No, displacement is x from its natural length.
Uh,
Sometimes the displacement will be 2x, sometimes the displacement will be 3x. But I have to find the work done. Suppose, for example, if I say in the last question, the particle was here, I have taken the displacement to be ds, or I have taken displacement to be s?
uh, okay, so means in that small displacement you are doing,
Yes. I
there
am
is no
talking
such
about
difference in
I am
force,
talking
but there
about
is a minimum
dw.
displacement.
I am talking about dw, not w. W I cannot find
মানে
because
ফোর্সটা একই থাকছে আর ডিসপ্লেসমেন্টটা শুধু dx হচ্ছে তো?
yes, I have assumed the force to be constant during that small displacement. Otherwise, the force is different at different value. How I can
মানে
multiply?
ওইটুকু ডিসপ্লেসমেন্টের জন্য আপনি ওয়ার্ক ডান ক্যালকুলেট করে ইন্টিগ্রেট করেছেন।
I am finding dw, not w. So the work done is minus half kx square. Yes or no?
ইয়েস স্যার।
All right. So till now we have discussed about work done. Now let us understand what is kinetic energy. Right. Kinetic energy, as you all know, that kinetic energy of a body of mass m that is moving with a speed v is given as, what is the formula for kinetic energy?
mv²/2
Half mv square. Yes, the kinetic energy for any body of mass m moving with a speed v is half mv square. That can never be negative. Can kinetic energy be negative? No.
No
Kinetic
sir,
energy
it's
is,
square in it.
yes, always positive or zero. Kinetic energy is half mv square. Now, what is kinetic energy? I can say that kinetic energy is energy due to its speed. More the speed of the body, more will be its kinetic energy. Yes or no? Yes.
Yes sir.
Yes.
So there are few properties that we need to understand about kinetic energy. First thing, it is energy due to speed. Second thing, it also depends on reference frame. Why kinetic energy depends on reference frame? Can anyone
So
tell me?
because the speed also depends on the reference
Yes.
frame.
Because mass is independent but speed depends on the reference frame. That is why kinetic energy also depends on the reference frame. Now there is another very important formula for kinetic energy, or law you can say, that says work energy principle. Right? It is known as work energy principle. What does it say? It says that we know that dw is equal to f into ds. If f and ds are in the same direction, let us take for example, then f into ds is the work done by that force. Can I just modify this equation as f equal to m into dv by dt? And on further modification, I will find it is ds by dt into
So
v.
how sir dv/dt came sir?
What is force?
Okay sir.
So can I say it is m into dv into ds by dt?
Yes, sir.
And what is ds by dt? Do you remember?
Yes sir, it's v.
Look,
dv.
now the function becomes m into v dv. So if you have to find what is the work done by all the forces, then I will find this work done from v initial to v final. Yes or no?
Yes, sir.
Yes sir.
What is a v dv integration? It is v square by 2.
v²/2
So can I say the integration will be half
half
m
a
v final
v²
square
minus u².
minus half mv initial square. So what is this? Is it nothing but the change in kinetic energy?
Yes sir, absolutely.
So can I say that work done is nothing but the change in kinetic energy?
Sir, I have a concept from I have a doubt from theory sir.
Yes. right? Okay. Look here, an observer is moving with 5 meter per second in the same direction as the object is moving. What is work done by 8 Newton force with respect to observer, and what is the change in kinetic energy with respect to the observer? Both you have to find in 2-second time interval. Very simple question. Now look, the observer is moving with a constant velocity, right? So there is no need to apply pseudo force with respect to the observer if I draw the free body diagram. So only 8 Newton force is there. So what is the acceleration of that 1 kg block?
8
meters per second square.
Right, 8 meter per second square is the acceleration of the block, right? And the observer is moving with constant velocity. So can I say that acceleration of the block with respect to observer is also 8 meter per second square?
Yes, the observer has no acceleration.
And what is the initial velocity of the block 1 with respect to
meter per
observer?
second, minus 5 meter per second.
Minus 5 meters per second.
Minus 5.
Yes, it is 0 minus observer acceleration velocity is 5. So it is minus 5 meter per second. Right? So what is displacement of the 1 kg block with respect to
So
observer?
what did you write that for?
So minus
A,
u.
1, so it is 0 or O?
It will be
So the second
is 0.
one.
It is
O,
observer.
observer.
It is acceleration with respect to acceleration of 1 kg block with respect to observer. With respect to observer. Right? It is the initial velocity. It is the initial velocity of 1 kg block with respect to observer. And this is the displacement. What equation I will write? Is it ut plus half at square? Can I write this equation?
Yes, sir. It is coming 6
What?
meters from me.
4 to 16 minus 10.
1 meter.
So 6 meter, right? And
Yes.
what is the force is 8 Newton. So what is work done by 8 Newton force with respect to observer?
48 joules.
Observer is 8 into 6. Both are in the same direction. So it is
Yes.
48 joules.
And that will be same from work energy theorem, second
Yes.
answer.
And what is the change in kinetic energy with respect to observer? Right? It is the final half m.
Total work done.
Yes, V final square minus half mv initial square, right? Look, if I only go with the definition of energy, not work power, not work energy theorem, then also I will get the same answer, right?
Half
What
m you
is,
take common.
yes, what is V final? V final is equal to U plus AT, right?
Minus 5 plus
V
8,
final
8
with
into
respect
2.
to observer
That's
is
11. 11.
A plus A into T. Is it 11?
Yes,
Yes,
sir.
sir.
So it is 11 square, and what is V initial? It was 5 minus 5.
That is 25 it will be.
Yes. So what is 11 square minus 25?
121 minus 96. Half into 96, 48.
96 by 2 is 48. Right? So I am saying that even if the work done and kinetic energy, these values are different in different reference frame, but the work energy principle is true in all reference frames.
So on reaching the ground, the speed of the stone will be same as the initial speed.
No, it won't be same.
No.
So speed on reaching the ground will be root over W minus R divided by W plus R into, in the outside will be U.
Alright, let us check. This was the ball. I have thrown it with some velocity u, and when it is in upward motion, you can see that the velocity of the particle is upward, so resistance force is also acting downward as well.
Yes.
Weight is also acting downwards.
Yes. So if I say that its maximum height is h, from work energy principle can I say that work done by W and R together will be minus W plus R into H? Is it the work done
Yes,
by all
sir.
the
Yes, sir.
forces? That is equal to the final kinetic energy is 0 minus initial kinetic energy is half mu square. Can I say that?
Yes, sir. I have done this.
So the
way.
value of H will be 2 into R plus W. Sorry.
Sorry, mu square by 2
Yes.
into R plus W.
So H is equal to M into U square divided by 2 into R plus W.
Yes, sir.
And M we have
Yes.
to do W by G.
W by G. So that is the answer for the first question. Right?
Sir,
Yes, sir.
why did you do W by J? I didn't understand.
M. Because M is not given. So I have
Weight হচ্ছে mg.
Okay. Yes, sir.
speed on reaching the ground. Now when it is here, the velocity is 0. When it will come down by h, the velocity suppose it is v, but during its downward journey its velocity is downward, so resistance
W
force is
minus R.
upward.
W
And
minus R.
Resistance
W-
উপরের দিকে.
yes, and w is downward. So what is now work done?
Resistance always opposing motion, no?
Yes,
Yes,
always
sir.
opposite to the velocity. So work done is can I say w minus r into h?
Hello.
Yes.
But
Can
the
we-
half
Yes,
mv
that's
square.
doing the work.
Yes.
And that is half mv square. That
Is it
equal
half
to
mv square?
Half mv square minus 0.
Yes, good. So the
Hello.
yes. Tell me what's the doubt? 2
I
into
think its
w
connection is
minus
gone.
r divided by 2 into w minus r into h divided by m under root of that, and what is the value of h? I can put it w u square, w by g means m u square divided by 2 into r plus w. Yes or no?
2g into r plus w. নিচে g থাকবে না একটা?
m আর w গুলো কেটে দাও.
Same or লিখেছি।
Yes. So is it u root over of w minus r by w plus r?
Yes, sir.
Okay, this question I'll give you as homework. First try to solve this one.
Okay.
স্যার আপনি কি বললেন এই লাস্ট 10 সেকেন্ড একটু বলবেন?
আমি এই কোশ্চেনটা সলভ করতে বলেছি, আর কিছু বলিনি।
Sir, is the answer 0?
No.
Sir, is it
So we have to use work energy theorem, no?
Only, yes. Work energy theorem only. First tell me what is work done by this force. Can you calculate it from the area under
Yes,
graph?
minus 0.25 joules.
minus 0.2?
2.25 joules.
Area under graph. Work done by the force is area under graph.
So
That-
here we can multiply because that it is in
Yes.
same direction
So
as
this is
displacement.
the positive work done, and that is the negative work done. Right? So what is that positive work done?
So 1.75
So the 1.75 minus 2.
minus 2
1.75 minus 2 is 0.25
Yes.
minus
Minus 0.25 joules.
minus 0.25 joule. So can I say this work done final is equal to half m v square minus u square? Yes or no?
Yes,
Yes,
sir.
sir. M is 2, so v square minus u square
So
is
can I
minus
say
1 by
v
4.
square minus u square is equal to minus 0.25 minus 5 by 2 sorry, minus 5 by 20 minus 0.25, let it
Minus 1 by 4.
minus, yes, 1 by 4.
Minus 1.
Yes,
So
one.
what is the value of u square? Is it v square plus 0.25?
Yes.
And what is the minimum value of u? Can I say in that case v should be 0?
Yes, sir. Okay. Yes, sir.
Oh.
So what it will be? 0.
0.5. So 0.5.
3.5.
0.
Sir, 0.5, I think.
0.05.
Yes, sorry.
0.5.
0.5.
0.5 meter per second. That should be the answer.
0.5. Oh, so means I have to find the means it is mathematical totally.
Yes.